Hello, today we are going to investigate the integral from 0 to pi over 2 logarithm of sine of x dx. Here, most books may write ln of x, or you may write ln of x, but that's the same thing. We just write log x to mean the logarithm to base e for x bigger than 0. So this is what we mean by logarithm of x. Now, how do we compute this integral? Well, we'll start off with the classical case of taking x to be pi over 2 minus theta. Now you may ask me, why pi over 2, why theta, why this substitution? Well, the thing is that this is actually a classical case investigated by Euler, the German mathematician. But the reason for this substitution will become clear as we proceed. Notice here that if you want to get the intuition behind the substitution, take the cosine of the sine of x. This will become the sine of pi over 2 minus theta. This will be what? Cosine of theta. And now you believe it because here we have logarithm of sine of x, but then we are going to have logarithm of cosine, and in due time I will show you why that is important to us. So, but first of all, we can just write the integral of 0 to pi over 2 of logarithm of cosine. We have to investigate, okay, since we have changed the limit from x to theta, what happens when x is 0? What is theta? So let's just see, if x is 0, then theta, then pi over 2 minus theta will be equal to 0. This means that theta will be equals to pi over 2. Now what about the case whereby x is equals to pi over 2? But this is the case whereby pi over 2 will be equals to pi over 2 minus theta. So this gives us theta is equals to 0. So this theta runs from pi over 2 to 0. So that is but x goes from 0 to pi over 2. That is different between them. But what about dx? Dx will be negative of d theta, because here dx will be pi over 2 is just a constant. So our integral, let's call it I, the integral from 0, not 0, but from pi over 2 to 0, I will become from pi over 2 to 0 of the logarithm of cosine of theta, because just as we have discussed here, sine of pi over 2 minus theta is just cosine of theta, the theta. But the theta had a negative attached, so we have a negative d theta here. But remember that obviously, as we have shown, that the integral from a to b is equals to negative of the integral from b to a. So we can change the order of integration, like the constant of integration. If we can just change the variables, flip it, we change the sign. So in this case, this whole I would equal the integral from 0 to pi over 2 over the logarithm of cosine of theta d theta. Now this is just similar to, like, we have just gotten two expressions for I. The first one being that I was the integral from 0 to pi over 2 over the logarithm of sine of theta, and then the theta, and then I is then said to be equal to the integral from 0 to pi over 2 over the logarithm of what? The logarithm of cosine of theta d theta. So we're going to bring these facts down to the next page. Let's go to the page, right? So what we have here is that I is equals to the integral from 0 to pi over 2 of the logarithm of sine of theta d theta, and then I is also equals to the integral from 0 to pi over 2 over the logarithm of cosine of theta d theta. Now when you add these two expressions, you get 2i being equals to the integral from 0 to pi over 2. Then we have logarithm of sine theta plus logarithm of what? Cosine theta, and then the theta. Now we can combine this because the logarithm of a plus the logarithm of b is the logarithm of ab when they are the same base, and here the same base is e. So what we have is that 2i would be the integral from 0 to pi over 2. Okay, wait, this is pi over 2. Let me write it well. So pi over 2 over the logarithm of what? Cosine theta sine theta d theta. Now notice that 2 sine of theta cosine of theta is just sine of 2 theta. So therefore sine of theta cosine of theta is just sine of 2 theta over 2. So we can write this as being equals to still yet 0 to pi over 2 of the logarithm of sine of 2 theta all divided by 2 the theta. Notice that logarithm of a over b is same thing as logarithm of a minus the logarithm of b. So over here we're going to have the integral from 0 to pi over 2 over the logarithm of sine of 2 theta minus the integral from 0 to pi over 2 over the logarithm of what? The logarithm of 2. Yep, the theta. Okay, this is the theta as well. Now notice here that for this second case, this is just equals to pi over 2 log 2. So this means that I is equals to the integral from 0. Okay, this is 2i, which is this 2i. 2i is equals to the integral from 0 to pi over 2. Then we'll have logarithm of sine of 2 theta minus what? Pi over 2 logarithm of 2. So let's shift over to the next page and compute our results. So we have arrived at 2i was equals to the integral from 0 to pi over 2 of the logarithm of sine of 2 theta d theta minus pi over 2 logarithm of 2. Now, how do we now evaluate this? Well, simply we let x, or let's say t, we let t be 2 theta. Now what happens when theta is 0? When theta is 0, t is 0. What about when theta is pi over 2? That means t is equals to pi. So in this case, t, when theta is 0, t is equals to 0, and when theta is pi over 2, t is equals to pi. So therefore this, let's just compute the smaller integral. This integral from 0 to pi over 2 of the logarithm of sine 2 theta d theta. Now notice that the theta is the t over 2. So because t is 2 theta, the theta will be the t divided by 2. So this is equal to half of the integral of 0 to pi of the logarithm of sine of t dt. Now this is essentially the same thing as the integral from 0 to pi over 2 of the logarithm of sine of t dt. And the reason being that we can always bring, since this function is periodic with period pi over 2, like we can always, there's a theorem in definite integral that like n times integral of 0 to maybe a of f of x dx. She's just essentially the same thing as the integral from 0 to na of f of x dx, when f of x is periodic. Okay, now that is what we have used here. So this is basically I. This is basically I. So that means 2i. I'll put it in red. 2i. Okay, 2i is equals to I minus pi over 2 times the logarithm of 2. So basically we can conclude that I is equals to pi over 2 logarithm of half, because we can always bring the negative above here to become logarithm of half. So this is the value of this our integral. Let's go back to the first page. So there it is. This is equals to pi over 2 logarithm of 1 over 2. So thank you for tuning in, and please do have a nice day. Bye.